Hello and welcome to the technology forecasting for strategic decision making. We made it this far. It's one of the most exciting modules I'm happy to introduce you to. We have done covered bits of this in the past about how to take data and look at the trend and predictions. We have done that in the past, but now we have a software provided by the Rockefeller University. They've been kind enough to share the code with us, and we are also happy to tell you that it's accessible for all learners at NPTEL. I'll demo this software to you, and you can, as learners, you can use this software and download the results for yourself. Use it as you can. Our request is for you to leave the copyright, the symbol in there to acknowledge the contribution of Rockefeller University's project. So that's our request to you. So I'm going to be showcasing the software itself. I'll just show you in a little bit what is the software all about. You will see, and we'll also play around with some data. What you can see is, first of all, let me show you the URL, the Universal Resource Locator. The URL is logletlab.nptel.ac.in. It's right here, up here on my browser, logletlab.nptel.ac.in. You don't have to enter the rest of the stuff, it's automatically input there. Once you have it in there, you will get to this page. It'll do since it's the first time. If you log in, it'll show you welcome to Loglet Lab. You can look at all this, and of course, if you're going to come here often, and I don't like, I mean, once I know what it is, you can also check out what are the different aspects of this software itself. There's a fit button. There's a guess parameters, choose number of waves, a library with some predefined set of data that we have, and input data that you will be using a lot. Okay, so that's the basic outline of this software. And I say, okay, there's a predefined library data. They're already there. Growth of a sunflower. I'll just show it to you how it's to be done. First, step one is to click on guess parameters. So it does a guess of parameters. Please refer to Professor Dimitri's explanation on what these parameters are in an earlier video. You should be able to find that out, what TM is, what K is, what A is, what D is. We have in this course only looked at one wave model, but if you know about this and you want to play around, please feel free. The URL is of course accessible to you. And then we click on fit. And if you scroll down, you will see the fit. It has the fit has been done. You can look at the growth of a sunflower and all the parameters listed here, and you can look at all the Fisher Price component analysis, all that we talked about in our earlier video. Okay, so as simple as that. This is it. So if you want to download any of these pictures for yourself, all you need to do is right click and click on save image as, and it's for you. I request you to leave the copyright in there, the copyright all graphs at PHE, which is the project which has provided us this software. So that's our request again. And now what we are going to do is we're going to input another set of data. I have looked at data.gov.in, and I've downloaded broadband from 2005 to May 2014. The source of data is data.gov.in. It's a CSV file, comma separated value file. Granularity is annual. Okay, so just go ahead and look at this annual data, and what I've already done is I have copied it into my editor, and let me see if I can show you. Uh, just a second. Okay, so this is the data that I downloaded from data.gov.in about broadband usage in India from the year 2005 to 2014. There's one data point that a loglet will not, loglet is the name of the software that we're using, loglet will not parse, which is the last one you can see, it's in May 2014. Okay, so normally, if you're touching data, you need to make a note of it somewhere. So in your documentation, you have to mention that you are tinkering with this data, or you're not including this data point in your analysis, because source data has this data point, whereas your final analysis does not. So you should make a note of this in your documentation. So here I'm just going to delete this data and save it, and we can copy the entire you know data point and go back to our loglet lab, which I will show you in a moment. We're back to and we are back to loglet lab, and here you can just copy this entire thing and paste it here. Okay, that's all you need to do. Now again, go back, step one, guess parameters, and fit, and it will do a job of fitting. Oh, I didn't change the title, so let me change broadband usage. Oh, not broadband, broadband usage in India. Well, on 2005 to 14, and now when you click on fit, it will do a fit, and you can see it has done the fit. Given you parameters, TM is 2010 midpoint. Okay, fairly good fit, and saturation is given, it is forecasted it. You can see that forecasted fit as a dashed line. If you do that, it will do. If you uncheck it, it will give you a solid line. Okay, so that's something we can do. If you want graph legend, you can do that, became smaller. If you want grid lines, you can add grid lines as well. Somewhere it should apply. Uh, Options, it will remember based on cookies. It has these will set cookies, so you will be able to see some of your settings saved. Okay, so all of this is there. From broadband usage in India, source of the data is data.gov.in. Okay, now I have another data that I want to show you, which is a fairly complex bit of data. This is average load of goods trains, broad gauge and meter gauge, up to 2013 to 2014. 2013 2014. It's a long data set. It's a big data set that I will download from data.gov.in. Thankfully, I've already downloaded this, but this is the source of data, data.gov.in. The entire URL will be posting. Okay, I'll show you what the initial data looked like. So this is the initial data that I downloaded from data.gov.in. Unfortunately, this is not usable as such because there is the in the year it's given a range 50 to 51, which is humanly understandable, but in parsing they still fail. So we need to remove that. Again, as I remarked earlier, whenever you are tinkering with data, always make a note of it. Let anybody you're sending a report to know that the initial data was this, and this is the data, let's say, for a lack of better terms, manipulation that you have done, and you have to clearly specify that, which is what I did. So I did a search and replace of you know and of changing the data. As you can see, the entire with regular expression I've done this, and it's changed. So no data, the year has been changed, but I made a note of what regular expression I used to parse the data. Okay, and replace it with the year alone. So that's one note to be made. Now I'll copy this data, and this is actually multiple sets of data. It has, as you will see soon, I will show it to you very quickly what we have done. Okay, yeah. So we're back here, and now I'm going to paste this data here. Okay, so I'm just doing copy and paste and nothing fancy about it. The same data that we removed the hyphen and the second next part of the year. We have removed it using regular expressions, and I will of course change this into railway statistics in India up to 2013 14. Okay, source is data.gov.in. Okay, the same way, this is now you will see that here there's a little change from the earlier one. Fit all as one data set. It is not one data set, but actually there are several data sets. If I go above, there is a heading here which you will see. I will shortly tell you what all data is there. And set parameters for all data. I tried it as each data set, and it gives me an error. The software is an error. Of course, I will take it back to the development team to let them know there's an error. But we will treat all data together. So that's what we will do. Two waves, you can mess around with this. Also, it gave me another error. So also I'm going to report back. Now we will guess parameters. It has changed the value. TM is 2013. It's treating all of it as one data set. There is an error. There is a problem with that treatment. And let's see what we get in fit. Okay, when you fit it, let's see what we got. It takes a while because there's a lot of data in there from 1950s to 2013. There were 60 years of data. The server takes a bit of time. We will soon see. Yes. So these are the terms that were used in the logistic was broad gauge number of wagons per train, broad gauge net load, broad gauge cross load, gross load, I'm sorry, broad gauge gross load, meter gauge, number of wagons per train, meter gauge net load, meter gauge gross load, incremental weight of engine, in tons, in terms of four-wheelers, tons. So all the units are also given. All the TM is given here, which is the median time point. So for each of these parameters, it's actually calculated it, and you will see a plot all of them together. It looks a bit messy. In case you want to plot it this way, you can certainly do it with predictions there. So saturation, what I don't like is the fact that it's actually these are some two-wave data, three-wave data. It's actually clubbed them all into one. We're not able to tease it out. One idea you could possibly do is open your CS favorite CSV software, just treat data by one after the other, and you can do it. There is a neat way to do it here. Separate plots. We can say graph all in one plot. So these options come when you go when you scroll down. You can get these options. It automatically appears. Just uncheck it, and you will watch what happens. It will actually separate out. The software actually separates out the plot. So here you can see broad gauge number of wagons per train. So as you can see, there are multiple waves in this. So it's not fair to treat it as one wave. And the after the Fisher Price transform rate is also here. Net load also, there are multiple waves. Okay, component analysis, you can see. Okay, so I wanted to take a complicated piece of data and then show you. Of course, here's a dip. Meter gauge, as some of you probably know, is phased out in India. So the number actually drops, and that's clearly seen by the prediction. Also, it's not complete zero, still there's some amount. So you can see when it will get phased out. Okay. um, so that's have fun with this data, with the software. Take your own piece of data, go to data.gov.in, download a CSV, Just make sure that all of this is numeric data. If there is non-numeric data, parsing is not so easy. As far as I know, I have to talk to the technical team over at Rockefeller University in New York to find out if that's indeed possible, if non-numeric data can be input here. But as far as I've seen, numeric data, and that too solid data like this, works very well, works really, really well. And have fun. Feel free to look around in the software, change any option. There are advanced options, graphing options, all you can just toy around. Of course, if you want to save, you can right click on this plot and say save image as, and save it to your desktop or your folders, and you can use it in any publication or anything report that you're generating out of this. So have fun, and let us know on the discussion forum what your experience has been with this software. We'll be happy to take your input to back to the Rockefeller team. And again, thanks to the Rockefeller University team for providing us with this software. Okay, so see you. Thank you so much. See you in the discussion forum then. Thank you.